Okay, so we're going to talk about two methods for data transfer. We're going to talk about interrupt-driven input and output and direct memory access, DMA. So those are the transfer methods. The main idea is how we can transfer data from the I/O device. Think about, for example, your keyboard. This is the input device, or output device. Think about your monitor and the screen. So between the input and output device and the memory. The question is how much the CPU should be involved. This is the main difference between the two methods, interrupt-driven I/O and direct memory access DMA. In interrupt-driven I/O, every piece of information we take from the I/O device to the RAM needs to go and the CPU needs to process it and to transfer it to the RAM. Namely, the CPU needs to be involved in the transfer of data from the I/O device to the RAM. This is not very good. If we look at the animation, we see that for each piece of data, the CPU needs to be involved and to take it to the RAM. Now, the idea of direct memory access is that we have a DMA controller that we can use instead of the CPU, and by that release the CPU to do whatever it wants and not work with that, let's call it a mesh or something, this mess, and the CPU is free to do what he needs to do, other things. And the DMA control takes control, and as you can see, the data, this is not the best one, the data can go from the I/O device to the RAM with the CPU being free, without the CPU being busy. Only at the end, when we are finished transferring all the data, there is interrupt to the CPU tells him we are finished transferring the data. Instead of every time making the CPU again and again busy, we can just transfer all the data one by one and without the CPU being busy. Only at the end, again, we are telling the CPU, hey, bro, we're finished doing this, so you can take control. And you know now that we transfer all the data. So the transfer, as you can see, the data is transferred without the CPU being busy. Only in the end, we interrupt the CPU. This is all thanks to the DMA controller that is the one that is busy transferring the data. It is the one that is active. So this is the main advantage of DMA, the direct memory access, not involving the CPU in the transfer of data from the I/O device to the RAM, freeing the CPU. So those are the two data transfer methods from the I/O to the memory that I want to talk about and show you that the DMA, the direct memory access, is more efficient. Now, there is overhead in DMA that I need a DMA controller. So if there is very little amount of data that need to be transferred, maybe interrupt-driven I/O may be more efficient. But usually for most of the more data needs to be transferred, this overhead of DMA control worth it to not make the CPU busy with transferring the data from the I/O device to the RAM. So those are the same things. Those are the methods that I wanted to talk about. Data transfers method, interrupt-driven I/O, and direct memory access using the DMA controller. Thank you very much.